So we're going to talk through some geometry vocabulary. So we're going to start with what is a point. So a point is simply a location in space. When we're naming a point, we're just going to name it using whatever letter is next to that point. So we're going to name this point as P. So it's also helpful to talk about the dimensions that a certain figure represents. And a point is what we would consider 0 dimensions. Okay. So next up, let's take a look at what we consider a line. All right, so a line is a series of points that extend in opposite directions forever, and that's why we put the arrows after it. We label this line as A, B, and we put a little line above those, or we could label it in the opposite direction, B, A. But you always need to make sure that you have these little line indicators over the letters so that whoever is looking at this knows what figure you're talking about. When we're looking at this line, we must have at least 2 points in order to construct a line. Okay. So then if we're thinking about the dimensions of a line, this is a one-dimensional figure. Now we're going to take a look at a plane. This is a flat surface in space that has no thickness. When we label a plane, we can label it in 2 different ways. So the first way we can label it is using this little letter down in a corner that is not attached to a point indicator, and we can label this as plane P. We can also use any 3 points on the plane, and we would name it plane L, M, N, and you can adjust those letters to be in any order. There must be 3 non-collinear points to construct a plane, and we'll talk about what non-collinear means in a minute. So space is simply the set of all points. Oops, all only needs 1, A. So this is the set of all points that are possible. So now we're going to get into what does collinear mean. Collinear means 2 points that are on the same line. Okay, so if I draw any line, points that are collinear are on the same line. Okay, coplanar is along the similar idea. Coplanar is simply objects, so points, lines, rays, whatever, that are on the same plane. Okay, so if we look at a plane, so I'll quickly draw one because we don't have the diagram. If we have points A, B, and C, we can say that points A, B, and C are coplanar. Okay. Segment. A segment is simply a part of a line that has endpoints. All right. When we name a segment, we name it similar to a line in that we're using 2 points, but very specifically, those 2 points have to be our endpoints. We can't use anything other than our endpoints. So we're going to name this segment using our endpoints x, y, and we're going to draw a bar above them indicating that this is a segment, not a line or some other figure. We can also reverse those. Y, x is also an acceptable way with our segment indicator above. A ray is simply part of a line that has one endpoint. Okay, so we have one endpoint here, that's X, and we can have points down along the ray. Whenever we name a ray, we always start with an endpoint. No matter what, we're starting, the first letter is going to indicate our endpoint. And then the other letter is just some point on the ray. So we could do X, Y, and then we put a little ray symbol above it. This symbol does not have to be pointing in any particular direction. Standard is to point towards the right, or X, Z. Opposite rays are two collinear rays with the same endpoint. So when you're thinking about these, you want to think that they make a line. So we're putting two rays together to kind of form a line, and this just happens to be the point where they're meeting. Okay, parallel lines. So we're going to add to our standard definition that we've been using for most of our math careers. And we're going to look at parallel lines and add a part of the definition. So now what's new is going to be that parallel lines have to be on the same plane. Okay. And we're keeping the standard definition of a parallel line that they do not intersect. Okay, so we're going to use this same symbol that we've always used, which are these two slash marks. Okay, and we would say that line EF, so we're going to name it EF, and remember it's a line, so we have to put that little symbol above it, is parallel to line GH. And again, it's a line, so it needs a little symbol above it. Now, if we want to indicate on our figure that these two lines are parallel, we do that by using little arrow markers on the line. So those arrows tell me that any lines with one arrow marker are going to be parallel to each other. So similar to parallel lines, but a little bit different, are skew lines. So these are lines that are not coplanar. So they have to be on different planes and do not intersect. So similar to our parallel lines is they don't intersect, but the difference is parallel lines are coplanar and skew lines are not. Okay, so now we've introduced this idea of planes, and planes can be parallel. So this is simply two planes that do not intersect. If you want to think of kind of the best example in real life, you can think of holding two sheets of paper and putting them like one on top of the other with some space in between. Just remember that real planes continue on forever. So paper stops and has a specific area. Planes are infinitely large. Okay. Perpendicular lines are two lines that intersect, and they intersect at a right angle. So that's at 90 degrees. And we use this little kind of upside down T to indicate perpendicular. And we can say that our two lines here, AC, and again, don't forget your line notation when you're naming lines, is perpendicular to line DB. And when we indicate this on a figure, that's where this little box here comes in. That's saying these two lines intersect at a 90-degree angle. So equal in geometry means basically the same thing that it always has, but here we're going to be talking about something very specific, and we're going to be talking about figures, for the most part, having the same measurement. So we're looking at two angles here, and we'll go ahead and look at how to name an angle while we're here. So our symbol for equal is the same. But remember, we're talking about measurements. We're not just talking about these angles. So we use a little m to denote measurement. So the measurement of angle, we use a little, just tiny little angle to mean angle. Measurement of angle 1 is equal to the measurement of angle 2. So that's how we're going to be writing angle. All right. So along with equals, we have this new thing in geometry called congruent, okay? So this is where figures have the same shape and size. We're going to go ahead and not worry about the second part of this definition right now. Okay, so the same shape and the same size. Okay. So we're going to go ahead and use a symbol that's a little squiggle line on top of the equal sign. So if we wanted to say that two angles are congruent, we would say angle 1 is congruent to angle 2. Now, the big thing about congruency is we are referring to the physical shape, not the measurement of something. So we're saying that if I picked up angle 1 and placed it exactly down on top of angle 2, they would overlap each other exactly. Okay, so we're not talking about just a measurement, we're talking about the physical figure, and that's the big difference there. Okay, so we don't use that measurement indicator because we're not really talking about that anymore. Okay, a postulate. A postulate is just a statement that is assumed to be true. Right? So it's assumed to be true. Someone stated it and we're like, yep, we're just going to take that as truth now. All right, an angle bisector or a bisector. We can bisect an angle as you see in this first diagram or a segment as you see in this second diagram. We cannot bisect a line or a ray because they're infinitely long. You can't do that, something infinitely long. So a segment, line, or ray that splits an angle or a segment into two congruent parts, okay? So an angle can be bisected by a ray, that's a ray, and a segment can be bisected by a line, like we see in the picture. It can be bisected by a ray, and it can also be bisected by a point. So a segment bisector is also defined as intersecting at a midpoint. So midpoint is just saying the middle, right? We want to think about the midpoint as the middle of a figure. Right? So we want to take a look at the postulates of geometry. These are the things that we are going to be assuming true. So first off, through any 2 points, there is a line. So that's saying if you give me any 2 points, I can draw a line through those points and it will be unique. Excuse me, there is one. There is one line. It is unique, okay? If two lines intersect, they intersect, we should say at one point. So if I have two lines and they intersect at a point. Okay, if two planes intersect, they intersect on a line. Okay, and I'm going to draw that one when I have some more space. Through any non-collinear point, there is exactly one plane. Okay, so I'm going to draw more examples of these down here. So postulate 1 says through any 2 points, there is a line. So if I have a point A and a point B, I can draw a line through those points, and I can't draw any different line through those points, okay? Postulate 2 says that if there are two lines that intersect, they intersect at exactly one point. They intersect right here at this point and at no other point. Okay. Postulate 3 says that if two planes intersect, they intersect at one line. I like to think of this like if I open a book and the pages on the left are one plane and the pages on the right are another plane, and the spine in between is the intersection point. So the best way to draw this is to actually start by drawing the line where the planes intersect. Okay, drawing the line where the planes intersect first, and then drawing the planes. So I'm going to have the left side of the open book over here, and then I'm going to have the right side of the open book. So this is my first plane, plane A. You can call it plane A. And my second plane, plane B. And they intersect on line CD. Okay. All right. Number 4. Through any three non-collinear points, there is exactly one plane. Okay, so I'm going to draw 3 non-collinear points. So point A, B. Now I can't draw C right here because I could draw a line through that. So I want to make sure they're non-collinear. So I'm going to draw it kind of off kilter. And I can draw a plane around those points. So if you want to think about this as almost connecting like a triangular shape. And that is going to represent our plane. You just want to remember that for planes, they really do extend in all directions. So really this plane does keep going here, but A, B, and C are on that plane.